Hello everyone, welcome to the Digital Electronics class. In this presentation, we will see the working of SR flip-flop and we will also try to find out the truth table for SR flip-flop. From this figure, we can see that this part of the circuit is a SR latch using NAND gates, which we have already discussed in the previous lecture on SR latch. We also derived the truth table of the SR latch using NAND gates. From the truth table of the SR NAND latch, we can see that when the value of the inputs S star and R star are both 0, then this is the not used case, because we cannot determine the outputs Q and Q bar in this case because it will be contradictory. So we don't use this case when the value of S star and R star is equal to 0. Similarly, when the value of S star and R star are 0, 1 and 1, 0, then we get the outputs Q and Q bar as 1, 0 and 0, 1 respectively. We also see that when the value of S star and R star are both equal to 1, then we are having the memory. For example, if the output was 0, 1 in the previous case, and if we give the inputs S star and R star equal to 1, then 0, 1 is being stored again. That is, we are again having the memory. The memory means that whatever the previous value was there is being stored again when the value of the inputs S and R are 1. Now we have modified this circuit by adding two NAND gates and we have given a controlled input or clock here. This clock is basically a controlled input because we don't want the inputs S and R to change accidentally. That is, we want these inputs to change only when we want. So for that purpose, we have introduced a clock here. Now from this circuit, we find that the value of S star and R star will be given as shown by these two equations. We find that this is a NAND gate, so the value of the output S star will be equal to S and clock complement, and from De Morgan's theorem, we can write this as S complement plus clock complement. Similarly, the value of R star can be written as R and clock complement, and by De Morgan's theorem we can write this as R complement plus clock complement. Now let us try to find out the truth table for this SR flip-flop. Now what is SR flip-flop? This whole circuit is known as SR flip-flop, and the clock which is given here is edge triggered. We can represent this circuit diagram by symbol shown in this figure. That is, we have represented the SR flip-flop by a box and the whole circuit is inside this box. So from this symbol of the SR flip-flop, we find that it has three inputs S, R and clock, and two outputs, namely Q and Q bar. Now this arrow on the clock represents that this flip-flop is edge triggered. If we do not have this arrow, it means that this flip-flop is level triggered. So this is the symbol of SR flip-flop. Now let us make the truth table of the SR flip-flop. We know that the truth table shows the relationship between the input and the output variables. So we have drawn a truth table showing three inputs, clock, S and R, and two outputs, Q and Q bar. Now let us find out the values of this truth table. Let us take the first case, that is when the clock is low, that is the clock is 0. Then if the clock is low, then the value of S star will be equal to S complement plus clock complement. Since the clock is 0, so 0 complement will give 1. Similarly, R star will be equal to R complement plus 0 complement, that is 1. So, the value of S star and R star will be equal to 1 when the clock is low. So, we find that when the clock is low, it means that the value of S star and R star is equal to 1. And from the truth table of the SR NAND latch, we find that when the value of S star and R star are both equal to 1, then we are getting the memory, that is whatever the previous state was stored in the flip-flop or the latch, it will be there. So, we can write this as memory. And we also find that whatever be the value of the S complement or R complement, the value of S star and R star will always be equal to 1. That is, S and R don't care. So, we have represented them as X. So, when the value of clock is low, we find that whatever be the input given to this SR flip-flop, then it is not going to change the stored value, that is, we will get the memory in this case. For this purpose, we have introduced the clock. That is, the main purpose for the introduction of the clock in a latches and making it the controlled SR latch. Now, suppose the value of the clock is 1. Let us see what is the value of S star and R star. When the value of clock is 1, then this becomes 0, this becomes 0. So, the value of S star will be equal to S bar and the value of R star will be equal to R bar. So, we find that in this case, the value of S star will be equal to S bar and the value of R star will be equal to R bar. So, it will depend upon the value of the inputs S and R. Suppose we are giving the value of S as 0 and R as 0 and the clock as high, then the value of S star will be 1, the value of R star will also be equal to 1. And again we find from this truth table that when the value of S star and R star are 1, we are again getting the memory. So, again in this case we will get the memory, that is when the clock will be high and the value of S is 0 and R is 0, we are again getting the memory. Now, suppose that the clock is high and the value of S is 0 and the value of R is 1, then in this case the value of S star will be equal to 1 and the value of R star will be equal to 1 bar, that is 0. So, from the truth table, when the value of S is 1 and R is 0, then we get the output as 0 and 1. So, in this truth table, when the value of S is 0 and R is 1, we will get the value as 0 and 1. Now, let the clock be high and the value of S is 1 and the value of R is 0. Then the value of S star will be 0 and the value of R star will be equal to 1. And from the truth table of the SR latch, we find that when the value of S is 0 and R is star is 1, then the output is 1 and 0. That is, when the value of S star is 0 and the value of R star is 1, we are getting the output as 1 and 0. So, in this case, the output is 1 and 0. Now, we will see for the next case, that is when the clock is high and the value of both the inputs are equal to 1. So, in this case we find that the value of S star will be complement of 1, that is 0, S R star will be complement of 1, that is 0, that is S star will be 0 and R star will be equal to 0. And from the truth table of the SR NAND latch, we find that when the value of S star and R star is 0, then this is the not used case. This is the contradictory case. So, when the value of S and R is 1 and the clock is high, you will get the not used condition. This is the contradictory case. So we find that this is the truth table of the SR flip-flop, and this is how we can derive the truth table of the SR flip-flop. So this is the truth table of the SR flip-flop. As you can see, this is the symbol of the SR flip-flop. So that's all for this presentation. Hope everything is clear to all of you. See you in the next presentation.